introduction to organic chemistry. Like what I mentioned, no, last time, ideally, Josh, yung analytical chemistry and organic chemistry, they must be discussed together. Because if you will notice, diba, there are problems in analytical chemistry that requires knowledge with organic compounds. So that's the reason why we will start this one as well. So hindi pwede yung parang Gen Chem approach tayo na puro Gen Chem lang siya, no? Hindi siya e-effect ngayon sa Anachem kasi analytical chemistry encompasses analysis of all compounds, including organic compounds. That's the reason why it's very fundamental for us to start our discussion with organic chemistry. So, etong first chapter naman natin, Josh, actually, majority ng nandito ay na-discuss na natin. No? So, ini-scan ko din siya. Yeah. So, majority ng nandito, na-discuss na natin sa Gen Chem at sa equilibrium. So, sabi ko sa iyo yung equilibrium, it will find its way pa rin sa organic chemistry. No? So, later, hopefully, at least 75% itong topic ay tapos natin today. No? So, please prepare your digital pad as well, Josh, no? Pati yung whiteboard mo later because I'll be giving some exercises then so that you can practice writing organic compounds, so especially their structure. Okay? So anyway, ayan. Okay na ba tayo, Josh? You're good?
Opo.
Okay, so let's start. So the first thing that we will discuss is all about carbon, no? So siyempre alam mo na yung carbon is number 6. That's your 6th element. And how many valence electrons per carbon, Josh? How many valence electrons? 4, correct. So that's the reason why magkakaroon siya ng 4 bonds, no? So if your carbon is now surrounded by 4 bonds, ilan ngayon ang electrons niya? In a sense, no? It will become kapag surrounded na siya ng 4 bonds, ilan na ang valence mo?
8 na po.
8 na. However, Josh, kapag sinasabi mong electron ownership, you will just count bonds as 1. So, for example, this carbon owns 4 electrons in organic chemistry, ha? Kasi kaya kailangan, medyo technical yung tanong dito. Let's say, this specific carbon, laging ganyan yung tanong dyan, this specific carbon contains how many valence electrons? 8 talaga ang sagot dyan. Pero kapag ang tanong ay, this carbon owns how many electrons? 4 ngayon yung sagot dyan. Okay? So, this is similar with double bonds as well, no? So, kung ito yung double bond mo, it will still have 4 electrons. Ito, Josh, tingin mo, ilan to?
5.
5. Kasi meron kang isang lone pair. So, count mo lang yung bonds. So, 1, 2, 3, then 4, 5. So, tingin mo, by your knowledge, Josh, ano yung charge nito? May charge ba ito?
CH3 po, plus.
Plus? Sige, tingnan mo. Babalik tayo. Ano ang formal charge?
Formal charge. Yung
group number. What is the group number of carbons?
Minus bonded.
Group number?
4 ba po siya?
Okay. Minus the
yung
bonded, which is over 2, di ba? Over 2 yon. So, that's 6 over 2. Kasi 2, 4, 6 yan eh. Minus lone pair. Tama? Ilan yung unpaired electrons mo?
2.
So, ilan ang charge?
Negative 1.
Okay, so this is actually a carbanion.
Ang carbanion po yan?
Diba? Anion siya, pero carbon siya. Carbanion. Pwede rin naman carb-anion. So parang hindi kasi kami nasanay na basahin yan na carb-anion. You can just say that it's a carbanion. Okay? So, ito yung sinabi ko sa iyo kanina, no? So, we have the formal charges observed with the common bonding patterns for carbon, nitrogen, and oxygen. Why these atoms? Because these three atoms will appear the most, no, sa organic compound. So, for carbon, please take note that you have 4 valence electrons, 5 for nitrogen, and oxygen ay 6. Okay? So, 6 ang sa oxygen, Josh, ha? Ito yung magiging zero formal charge nila. So for carbon, how many bonds, Josh? Para maging zero ang formal charge. Review lang tayo. How many bonds for carbon?
4.
Zero ang formal charge.
4 po.
4. Do you have any lone pairs?
No more kasi na okay pa na pala.
Good. How about nitrogen? How many bonds?
3.
3. Do you have any lone pairs?
No.
For nitrogen, for your nitrogen to have a zero formal charge? Correct yun, 3 bonds. 3 bonds ka, correct.
3 may lone pair po.
Good. How many lone pairs?
1.
How about oxygen? How many bonds?
H2.
2.
2 bonds, 2 lone pairs.
Very good. 2 bonds, 2 lone pairs. And that will have, or that will give you a zero formal charge. However, Josh, ito ngayon yung mangyayari. Kapag yung carbon mo ay 3 lang yung bonds and walang lone pair, dun siya magiging positive. Anong tawag mo ngayon dito? Tingin mo, anong tawag mo dito? Sa carbon na may positive charge, 3 lang yung bonds. Ito yung carbanium, di ba? Nasabi ko na to kanina.
Opo. Tapos yung radical?
No. Radical is may unpaired electron ka. So kung anion to, this is cation, right?
Opo.
So ano kayang tawag? Carb-cation? Kasi carbanium eh.
Kaya pala carbanion.
Carbanion. Oo, kasi nga anion siya. Ito cation to. So ano kayang tingin mong term? Carb-cat yun. Carb-cation. Ang term natin ay carbo.
Meron po. Baka siguro kasi baka siguro carbo-cation.
Carbo-cation. Ang tawag dito ay carbo-cation. Positive siya. Okay? Pag yung nitrogen mo from 3 bonds na may isang lone pair, naging bond yung lone pair, ammonium ion ang tawag dito. Okay? So, N+ yan. Okay? And then, oxonium ion naman kapag sa oxygen. Okay? Yung oxygen Diyos siya, pwede rin siya magkaroon ng positive charge pag 3 na yung bonds niya. Okay? And then, nitride ion to, no? So, yung N-. Tapos, ang oxygen minus naman ay oxide minus. Please take note, Joshua, kapag negative charge, what can you say about the atoms? Ano nangyayari sa atoms mo? Again? Pag naging negative siya, -1, ano nangyayari sa atoms mo?
Ano po yung gusto mong, ano po yung gusto niyang sabihin?
Dun sa central atom mo, kay carbon, nitrogen, and oxygen, if they're having a negative formal charge, what happens to their bonds and lone pairs?
So yung lone pair nung wala lang. Dumami po yung bonds niya. By 1.
Dumami yung bonds?
Opo.
Pag negative ang formal charge?
Sa carbon po nawala. Sa nitrogen and oxygen, dumami.
Ang bonds? Dumami ba yung bonds nila?
Nawalan pala. Baliktad pala. I was looking sa 1. Yung sa -1, nawala yung bond. Naging lone pair.
Yun kasi yung pattern, Joshua. Yun yung pattern. If you're moving from zero formal charge going to a negative formal charge, you expect that you'll be losing a bond and then you'll be adding a lone pair. Kaya siya magiging negative. Basta parang lagi mong isipin dito, Josh, ang lone pair ay negative. So kapag dumami yung lone pair, mas magiging negative yung atom mo. Ngayon, if you're moving from zero formal charge going to a positive formal charge, dadami dapat yung bonds mo dito. Okay? Ideally dito kasi kay carbon, nakita mo, Si carbocation, nabawasan siya ng isang bond tapos naging positive siya para maging carbocation. But for nitrogen and oxygen, generally speaking, you'll be adding more bonds and then they will have a positive charge this time. Okay? So next, ang next topic natin ay resonance. So alam mo na to. Explain mo nga yung resonance. Bakit tayo may resonance?
Kasi baka hindi siya gano'n yung pag-distribute ng ng electrons talaga.
Anong hindi gano'n yung pagka-distribute ng electron?
Hindi po siya equally distribute. Hindi po siya parang...
If it's not equally distributed or properly represented, ano kailangan mong gawin?
Delocalization?
Yes, so kung may delocalization, ano nangyayari? Sige, continue. Continue mo yung explanation mo. It makes sense.
Yung merong electron na hindi siya owned by one specific atom.
Okay, so therefore?
So therefore, it's within the...
in the middle. No, therefore, we must use another representation to represent that same molecule. So imagine mo ha, Joshua, ang resonance ay iisang molecule lang. Okay? Pero since your electrons are delocalized, sasabi mo na yung term, no? So electrons are moving from one atom to another, no? So you're changing the number of bonds, no, between two atoms. We cannot represent it in one molecular structure only. So doon ka magkakaroon ng resonance. And resonance is of course, as review, no, represented by a double-headed arrow. So guys, Joshua, pakitandaan, ang structures, ang resonance structures or resonant forms ay para sa isang structure lang na we cannot represent it alone because of delocalization ng electrons. So two Lewis structures having the same placement of atoms but a different arrangement of electrons. So very important din dito, Joshua. Please remember, hindi mo babaguhin yung attachment ng atoms. They must be the same. Kasi same molecule lang din naman yan. Nagkakaroon lang ng another representation due to the localization of electrons. Okay? So, neither resonance, for example, for this one, so you have here an aldehyde, hindi na ito aldehyde. So your carbon is both bonded to oxygen and nitrogen. This time, your nitrogen contains the negative charge. But due to the localization, so pwede rin ito na yung curved arrows, Joshua. So itong lone pair mo dito sa nitrogen, pwede mo siyang ibigay sa bond between carbon and nitrogen so that you'll have double bonds here, no? So ngayon, ang mangyayari dito, Josh, tignan mo to, kapag yung nitrogen, binigay yung bond niya between carbon and nitrogen, what will happen to your carbon? How many bonds na siya?
Naging ano na po siya, naging nag-4, tapos naging...
Itong lone pair na to, binigay dito between carbon and nitrogen. What will happen to your carbon this time? How many bonds siya?
Para siyang 5 bonds.
Oo, so hindi naman pwede yung kay carbon. Sobra yun sa kanya, no? It's too much for carbon. Therefore, carbon will give up the bond between carbon and oxygen. So yung isang bond lang, no? So that this pair of electrons will now be transferred to your oxygen, so to form an oxide ion. Okay? So the true structure, so ngayon, ang tanong ko dito, Josh, sinong tamang structure ng molecule na to? A or B? Si HCO and H-. Sino ang tamang structure niya?
Neither.
Very good, neither. Ang tamang structure talaga is yung composite ng both resonance forms. And anong tawag natin doon? Yung combination ng mga... Again?
Yung resonance hybrid.
Okay, good. The resonance hybrid structure. That is our correct form, no? So, Resonance allows certain electron pairs, no, to be delocalized. So when you say delocalization of electrons, neither atom owns the electron. So therefore, electron must be moving around, no, in a group of atoms. So therefore, kailangan mo talaga mag-resonance structures. Kapag mas marami ang resonance structures, ano masasabi mo sa structure, Josh? Or sa molecule? If you have more resonance structures. Uy, na-review lang to. Pag mas maraming resonance structures, ano masasabi mo sa molecule? In terms of stability. In terms of stability.
Stable po yung mga electron, ano?
In terms of stability, kunwari naalala mo to, di ba, yung benzene. Di ba, this is benzene. How many resonance structure for benzene?
1, 2. 2 lang po.
2. So, ito kasi yung dating dilemma nila no? So, sobrang stable kasi ni benzene. So, ibig sabihin, dapat meron siyang explanation. So, benzene will have 2 resonance structures. So, what can you say about the stability of benzene? Of course, by physical knowledge, no, benzene is really stable. So, ngayon, Joshua, a molecule with 2 or more resonance forms is said to be resonance stabilized. Yun yung sinasabi ko dati dun sa Gen Chem natin na if you have more resonance structures or more resonance forms, the molecule is said to be stable. No? Actually, it's more stable. No? So, kasi nga, marami siyang pwedeng puntahan na molecular form, kumbaga. No? So, that's the reason why it's resonance stabilized. So, these are the basic principles of resonance theory, very important to Joshua. Number 1, resonance structures are not real. So an individual resonance structure does not accurately represent the structure of a molecule or an ion. Only the hybrid does. Kasi nga, ano yung real form natin or real representation ng molecule kapag may resonance, Josh? Ano yung real representation natin for a molecule with resonance?
Yung parang ganun po na ano, yung parang yung may...
Anong tawag doon?
I don't know po, yung ganun na parang cake, yung ano, yung kasabay ni Kiko na yung ganun na
yung ring or para mapakita yung delocalization.
Aromatic.
Hindi aromatic ito. Hindi aromatic. In a general sense. Walang tamang resonance form kasi nga mali sila parehas. Only, sino lang yung tamang resonance form? Yung resonance hybrid. Okay? Yun ang resonance hybrid structure siya ang tamang representation ng molecule kapag nagre-resonance yung molecule mo. Okay? So, next, let's proceed. So, resonance structures are not in equilibrium with each other, So, hindi applicable yung equilibrium concept sa resonance structure, Josh. There's no movement of electrons from one form to another. However, we can do curved arrow notation so that we can just indicate the movement of electrons. So please take note, Josh, another theory, another statement about the resonance theory. Resonance structures are not isomers. They just represent the same molecule. Nag-iiba lang yung arrangement ng electrons. Okay, so two isomers differ in the arrangement of both atoms and electrons. However, in your resonance structures, they differ only in the arrangement of electrons. Kapag nag-iiba lang yung arrangement ng electrons, resonance structures ang tawag natin dyan, not isomers. So, sa isomers kasi, nag-iiba yung attachment ng atoms sa electrons. So, pero naturo ko na sa'yo, di ba? May mga isomers na same yung attachment ng atom. Sige nga, anong tawag sa isomers na magkaiba yung attachment ng atoms nila? Kunwari, aldehyde and ketone, yan. Usually, mga ano yan isomers yan sila. Maalala mo yung term natin? Naturo ko na yan. Kunwari, ito bigyan kita example. Acetone. So this is acetone Can you give me the formula for this?
CH32.
C2.
Okay, so it's the same thing.
C2H6CO. Tama ba? C2H6CO. How about this one? C2H6.
CO pa rin.
CO
Pero
din.
yung
Di ba same sila? Pero magkaiba sila ng attachment.
Opo, yung isang CH2
This
na
is
po siya.
this is a ketone, this is an aldehyde. Ayan. So, wag mo muna intindihin din yun. Pero alam mo na yung ketone and aldehyde eh. Generally, may idea ka. Pero, anong tawag mo ngayon sa dalawang yan? Isomers ba sila? Yes or no? Or resonance ba sila? Isomers or resonance?
Isomer.
Isomer yan. Kasi hindi yan resonance. Kasi magkaiba yung attachment ng atoms eh. Ang tawag dito ay? Yes, again?
Should there be a term for yung totally different? Parang ito pa totally different siya eh. Kasi iba po.
Ang tawag dyan ay letter C. Naalala mo na. Naturo ko yan last time sa mga isomers. Ayan na. Ano na, dudugtungan mo na lang yan. Anong tawag dito? Ketone and aldehyde, they are?
Wait. Ketone and aldehyde.
They are what?
Ano pong last letter? Ano pong last letter?
Oy, constitu. Oh, ayan na.
Constitutional isomer?
Oh, yes. They are constitutional isomers, no? So, constitutional isomers yung dalawang yan dahil same sila ng formula pero different arrangement ng atoms. Pero 'di ba may nasabi kasi ako last time, Josh, may mga isomers na same talaga yung arrangement ng atoms, same din yung attachment ng atoms. I mean, same attachment of atoms but different arrangement in space. So parang kunwari nasa left lang yung isa, nasa right lang yung isa. Anong tawag natin sa mga 'yon? Ayan. So, constitutional isomers, same formula, same molecular weight, different attachment of atoms. Pero yung iba naman, katulad nito, Josh, ito. What can you say about the methyl group ng butene na to? Yan. Bigyan mo nga to ng formula. Anong formula nito, Josh?
C4.
C4? Tama, C4 yan.
Yung ganon? Yung ito po yung sabi niyo parang iba po yung parang trans.
Oo, yan. Parang mga cis-trans talaga to. Hindi to parang cis-trans. Cis-trans talaga yan. This is C4H8.
Stereoisomerism. Opo.
Very good. Stereoisomers ngayon yan. Okay? Naalala mo pa. So, kasi nga, sabi ko sa iyo, hiniram lang din naman ng organic yung concept ng inorg, no? So, sa inorg, naturo ko na yan, yung sa GenChem natin, constitutional isomers at stereoisomers. Di ba, anong compound sa'yo may stereoisomerism? Naalala mo? Sa GenChem? Saan compound sa'yo nun? May stereoisomers?
Yung mga hydrocarbon, etc. mga...
Ay, hindi hydrocarbon. Di pa nga tayo nag-hydrocarbon. Ano yun?
Ito parang yung model, di ba po yung mga CCl?
Yes. Totoo naman na nagbigay ako ng example. Pero sa inorganic chemistry, saan mo usually makikita yung mga stereoisomerism? Complexes, very good, di ba? Complexes, sa coordination compounds or complexes, they will give you constitutional isomerism tsaka stereoisomerism. Anyway, sabi ko nga sa iyo, review lang ito no ng resonance structures, more on bonding talaga. Sa organic kasi very important, Josh, na very clear yung concept mo no ng ating bonding. That's the reason why binabalikan natin tong resonance. Mamaya babalikan din natin yung ilang concept dito ng molecular geometry, etc. So that we will be clear no with the different concepts ng bonding. Wait lang Josh ha. Saksak ko lang ang aking charger. Okay, going back, so let's draw some resonance structures this time. No? So rule number 1, two resonance structures differ in the position of multiple bonds and non-bonded electrons. So the placement of atoms and single bonds always stays the same. So make sure, no, yung mga arrangement mo ng atoms, saka yung bilang ng mismong single bond sila, laging same yan. So it means bare minimum yung meron kang single bond. Kasi kapag naputol yung bond mo, ibig sabihin mawawala yun, mag-break apart yun. Hindi na sila resonance structures, no? So, for example here, this pair, the position of a lone pair is different. So, this lone pair is present sa nitrogen for letter A, pero sa letter B mo, napunta lang yung lone pair kay oxygen. However, yung lahat ng single bonds mo, nandun yan. So, lahat ng atoms mo, they're connected in the same way. Pero yung double bond can be different as well, no? So, because the double bond here in letter A is present in between carbon and oxygen, while for letter B, carbon and nitrogen naman. So, yung may double bond ka. So, rule number 2 naman, two resonance structures must have the same number of unpaired electrons. May tanong ako dito, Josh. How many unpaired electrons for letter B? Si letter B na lang muna tayo.
B, 1, 2, 3, 4, 5, 6.
How many unpaired for letter B?
8 po.
For? How many?
8.
Unpaired electron, yes, unpaired electrons ay 8, no? Or lone pairs niya ay 4. Correct. Pero pag tinignan mo dito sa kabila, ayan, how about this molecule, Josh? How many unpaired?
How many? 1, 2, same pa rin po. Wait, no. 1, 2, 3, 4, 5, 8, 10.
8 unpaired electrons, pero how many lone pairs?
4.
4 lone pairs. And meron kang
unpaired.
additional. Okay, may additional ka. Ngayon, tignan mo ha, the same yung arrangement ng atoms, di ba? Same yung attachment nila. HCONH, correct? Pero are they the same compound?
No. Are they? Possibly, yes.
Possibly, yes. However, are they the same resonance structure?
No.
Okay, good. So magkaiba yan kasi nga, magkaiba din yung bilang mo ng mga electrons ha. So rule number 3, resonance structures must be valid Lewis structures. So valid dapat yung Lewis structure mo ha. Very, very important. So as much as possible, your carbon will have 4 bonds. 4 given yung 3, pero bihirang-bihira yung 5, no? So theoretically pa lang yung 5 bonds for carbon, no? So lagi lang siyang 4 or 3. So kapag 3 siya, Josh, doon ka magiging positive, carbocation.
And no na more than 5 yung carbon.
At saka meron palang dito, may statement dito, no second row element can have more than 8 electrons. Why do you think so? Sino yung second row element mo? Mga second row elements mo, sino yun? Sa P-block, punta ka sa P-block. Sino yung mga second row elements mo?
Second row elements, may lang po. Below, na carbon?
Hindi. Second row na nga si carbon eh. Ang first row mo, hydrogen and helium. Boron, carbon, nitrogen,
fluorine,
nitrogen before fluorine. Ano? Nitrogen,
Oxygen.
boron, carbon, nitrogen, oxygen, fluorine, and then neon. Ang tanong dito, Josh, bakit hanggang 8 lang sila meron? Bakit hanggang 8 electrons lang sila? So it means, di ba, parang octet rule lagi sila. Pero tignan mo, ano yung, let's say, example which element or what element is under nitrogen? Boron, carbon, nitrogen, oxygen, fluorine. Anong element ang under ni nitrogen, Josh?
Three. So, yung ano?
Guess what element is under nitrogen?
Wait. Aluminum, silicon, phosphorus, yes.
Phosphorus. How about oxygen?
Sulfur.
Okay. I have a question, Josh. How many bonds ang phosphorus? Hanggang ilang bonds? 5. And how many valence yun? How many valence electrons yun? Kasi 5 bonds eh.
So 10.
That's equivalent to, okay, 10 valence electrons yan, no? How about for sulfur? How many bonds? Hanggang
6.
how many bonds? 6. Tama, 6 bonds.
6 lang?
6 bonds.
Yes, tama. Octahedral.
So, how many valence electrons? Up to?
12.
Okay. Ito ngayon yung tanong ko. Bakit sila boron, carbon, nitrogen, oxygen, fluorine? Nililimit lang natin yung second row elements to 8 and 8 valence electrons. Why cannot go beyond of 10? Let's say we'll have 10 valence electrons for nitrogen as well, 12 valence electrons also for oxygen. Ano nga ulit yung reason dyan, Jo? Ayan, kine-check ko ulit yung concept mo ng bonding. Ilang beses natin diniscuss yan. Bakit kaya?
Bakit po may
oh yeah, bakit sobrang obeying ng second row sa octet rule? No? They're really obedient with the octet rule.
So they can get a full valence cell. It's most likely na 8.
Yeah, why? Why only 8? Yun yung tanong. Why only 8? However, tignan mo ha, si phosphorus ka, group niya si nitrogen, pero si phosphorus hanggang 10 valence.
So they can become more like noble gases.
No. hindi ganyan yung explanation. Babalik ka sa hybridization. Hybridization yan, yung susunod.
Yung hybridization is...
May tanong ako, Josh. Ano ang kasunod ng 2p? Anong orbital ang kasunod ng 2p?
Orbital 2p. 2s?
2s. Di ba? 1s, 2s.
Yung
2p.
ano po, 1s, 2p, 3s.
3s, wait lang. So, yung second level mo, sila boron, carbon, nitrogen, oxygen, fluorine, nasa second level sila, na second energy level due to their 2p orbital. Then the next orbital is 3s. The difference between the two is quite high, no? So, ibig sabihin, the electrons coming from your 2p cannot actually occupy the 3s orbitals already. Malayo na kasi yung difference ni 2p at saka ni 3s. However, punta ka sa third row mo, Josh. Anong kasunod ng 3p? Anong kasunod ng 3p?
3p, 4s.
Kasunod ng 4s?
4s, 4p.
Oh, hindi Hindi 4s.
4s, 3d.
3d. However, 3d is in what energy level?
Nasa ano na ba?
3D. Anong energy level yan?
Hindi po.
Nasa 3 din. At kasama niya sila 3p. Diba? Yung third row mo, sila aluminum, silicon, phosphorus, sulfur, chlorine, meron silang empty 3D orbitals. Kaya kapag nag-hybridization, ginagamit nila yan. Diba? Nag-extend sila phosphorus and sulfur. Diba? Ang mga hybridization natin, sp1, sp2, sp3, sp3d1, sp3d2, which is kaya nang gawin ng third row elements mo. Ngayon, sila boron, carbon, nitrogen, oxygen, and fluorine, hindi nila kaya mag-occupy ng third energy level na orbitals. Kasi nga, it's too high for them. No? So therefore, very obedient lang sila sa octet pool. No? Usually hanggang 8 lang yan sila. Then, next, we'll have a curve arrow notation. Just very quick. So the curve arrow notation is actually not a new idea to you because I already introduced this during our Gen Chem days, no? Lalo na yung chemical bonding. So it's a convention that shows how electrons position, so how electron positions differ between two resonance forms, no? So parang tinitingnan natin dito sa curve arrow notation yung movement ng mga electron pair. So please take note, electron pair ang gumagalaw dito. So kapag dalawa ang gumagalaw, Josh, full-headed arrow ka. Ayan. Pero kapag isang electron lang ang gumagalaw, tsaka ka nag-half. Ayan. So, eto Josh, by notation to ha. Ilang electrons ang represented nito? 2. Eto, 1. Okay? So, ngayon, yung tail ng arrow, dun ng...
po.
Edi pwede kang full-headed arrow, tapos may isa pang half arrow. Ganun yung mangyayari.
Parang may extra.
Yes, may mga ganitong bonds eh. Kunwari ganyan. Ano meaning nito? Ano nangyari sa sa bond mo? Kapag ganyan yung notation.
Nawala po. It's gone. Totally po.
Okay, and then how is the bond broken?
How is the bond broken? By all of the electrons moved away.
Oh, yeah. Pero anong movement ng electron sa bawat side? Tig? So, the bond is broken equally, no? So, ayan na, nag-i-start na tayo ng other organic concepts. So, the bond is broken equally. So, that's homolytic bond cleavage, no? So, homolytic bond cleavage siya. So, ngayon, dahil equal yung pagkaka-break mo ng bond, so yung tig-isang side ng bond ay makakatanggap ng tig-isang electron. No? So, yan yung mangyayari. So, please take note that the tail of the arrow begins at the electron pair. So, yung tail, Josh, very important to. Very particular kaming mga chem majors sa arrow pushing at saka mga arrow notation. No? So, kung saan manggagaling yung electron pair, doon magsisimula ang arrow. Kung saan naman siya papunta, doon pupunta yung electron pair sa part na yun. So, papunta sa atom na yun or papunta sa another bond, etc. Okay? So, ayan, katulad nito, no? Move one electron pair from one side of your carbon. So, from left side, pupunta sa right side. And if you will notice, tignan mo to, Josh, very important ito. What can you say about the right side metal ion? Ito. Ano masasabi mo?
So it has a unpaired electron.
May unpaired electron ba siya? Ito? Yung ito, oh. Yung CH2 na yan?
Wala po.
Pero isa siyang kung side na to. Nasa kanya yung what can you say about this carbon? This carbon is what?
Electron.
Nasa kanya yung electron? Hindi, check mo, tignan mo. What can you say about that carbon?
1, 2. It's perfectly normal po?
It's not perfectly normal. Anong meron sa carbon na yan? Sa right side. Yung binilugan ko ha.
Opo. 1 bond, 2 H, and 1 unpaired electron.
And hindi, may unpaired electron ba siya?
Opo, nakita ko.
Wala siyang unpaired.
Plus charge pala yun.
Plus charge lang yan. So it's a plus charge, no? So therefore, ano yan? Anong tawag mo sa carbon na yan?
3 ano lang po, 3 bonds lang. Yun yung carbanion ba?
No, it's a carbocation.
Carbocation.
Anong masasabi mo sa left side na carbon? Carbocation yung right side. How about the left side? It's just a normal carbon na may apat na bonds, right? Pero nung nilipat natin, magkakaroon ng resonance. Nung nilipat natin yung bond na yon, anong nangyari sa charge mo? Kasi nilipat natin yung ano eh.
Naging plus lang po siya. Entirely.
Nilipat natin yung double bond na to sa kabilang side. So ngayon, yung carbocation mo dun sa right side, siya ngayon yung naging normal carbon. And then the carbon on the left side now will becomes the positive one, will now have the positive one formal charge. No? So this time, this one will become your carbocation. Ganyan yung nangyayari. No? So, paano kapag dalawang electrons yung gumagalaw? No? So, dalawang pasahan. So, let's say ito. Anong tawag mo sa carbon na to, Josh? Ayan. Sa example 2 tayo, Josh. Ito. Anong tawag sa carbon na yan?
Yun yung ngayon po siya na yung carbocation.
Carbocation ba ito?
Wait. 1, 2, 3, 4, 5. Yun yung carbanion. 5 po.
Okay, carbanion yan. Tapos, tingnan mo ha. Yung carbanion, pinasa niya yung lone pair niya dun sa kasunod na carbon. No? So, it will form a bond now this time to its adjacent carbon. However, ano mangyayari sa bonds ni carbon na katabi niya, Josh? Ito, tignan mo to. Kapag gagawa ng bond, yung carbanion, papunta dun sa carbon na adjacent sa kanya, what will happen to the number of bonds ng carbon na ito? Nung katabing carbon?
Normal.
Magiging?
Magiging 4 bonds na rin po siya.
Magiging 4 bonds. Hindi, nagpasa ka na nga eh. Ayun di ba? Ipapasa mo yung lone pair na to between this carbon. So what will happen to your carbon this time? Ito. I'm now asking to this carbon.
Magiging... wait. Mag-shift po yung mag-shift po naman yung isang bond. So magiging 4 ano po?
Originally, mag-shift naman talaga based dyan sa no? Sa arrow pushing. Pero kapag wala kang shifting na mangyayari, magiging 5 bonds kasi siya. That's the reason why, yes, very important to Josh that's the reason why i-check mo yung kasunod na carbon kung tama pa ba yung formal charge niya at yung number of bonds niya, no? Yung allowed number of bonds pa ba yan? Kasi kapag hindi, i-give up niya ngayon yung next bonds. And ngayon, tingnan mo, Josh, pwede rin naman maputol to, di ba? Yung carbon to methyl. Ayan. Siya yung mapuputol. Di ba? Bakit kay oxygen? Ayan.
Kay oxygen kasi, I don't know. Hindi po siya pwede sa kabilang carbon. So, oxygen na lang po kasi there's nothing else. Meron po ba pong...
Hindi, kasi kapag give up niya yung kay methyl, ano mangyayari sa methyl bond? Yun yung unang obvious answer eh.
If this carbon, siya na po yung magiging carbanion.
Correct. Makakat ngayon siya. Hindi resonance yun. Hindi na resonance yun. Kasi nga, hindi na sila same molecule, no? Pero ito yung susunod na question. Ito na yung susunod na clue mo. Yung mga bonds, yung mga electronegative elements, Josh, sila yung usually nakakakuha ng more electrons. Kaya ang mangyayari, yung double bond dito between carbon and oxygen, this bond will be given up so that your oxygen will obtain another lone pair and siya ngayon yung magbe-bear ng negative charge. And it's okay for oxygen because oxygen is what again? It's a okay lang na magka-negative charge siya kasi oxygen
negative.
is what? An electronegative element. Kaya okay lang sa kanya mapunta yung lone pair. No? So, kaya magkakaroon ka ng oxide ion dyan. So, before we proceed with molecular shape, no? So, wait lang. Before we proceed with molecular shape, Josh, stop share lang ako. Tapos, so ngayon mo mag-share ng whiteboard. Wait lang, i-scan nga lang din ako dito. Okay, dito siya. Ayan ha, bibigyan kita ng example and then tell me kung ano yung mangyayaring resonance dito or bigyan mo ko ng mga resonance structures niya. So, ito kunwari yung una. H2, double bond, C, double bond, C, O, okay. Ayan, try natin to. Tapos ito naman yung second. Okay. So, ano lang, ayan. Ayan, sige. Can you give me resonance structures for these two structure? Try to propose, Josh.
Ito na po. Ito na po yung part ng mga even structure. Resonance structure.
Propose as many as you can.
As many as I can. Hybrid po or ano lang? Ano lang?
Hindi, kahit yung resonance form lang, yes. Another resonance structure or resonance form.
Actually, very sad po ito kasi I cannot make an IELTS.
Kaya mag-a-arrow pushing ka ngayon dyan. So, usually, kung saan yung negative side, doon nag-i-start ang pasahan ng electron. Yes, passport. Apo, parating na yun. Okay. You indicate the arrow pushing, ha? You can you can start from my my drawing or my structure. Di ba? So from the
This is diamond.
dalawang kanto, Josh, kapag yung isang double band dyan ay nilipat mo, ilan na yung lone? May nilipat ka bang lone pairs ng oxygen? Di ba dapat tatlo pa rin siya? Nagets mo yun? Nagets kita doon eh. Kasi ang gusto mo, eto, ililipat mo siya dito. Is that plausible?
Alam ko na po yung tama.
Tignan mo, ilang bands na yung carbon mo pag ganon. Diba? Ayan. Sabi ko sa'yo, matcha-challenge ka dito eh. Resonance structure pa lang yan, ha? Ginagawang para sa tubig ka rin, di para bukas. May bakanting lote na tapos ang tatlong apartment. Yung tatlong apartment is going to be.
Okay.
Sige. Yan yun. Yan din yung original na structure. Yan yung drawing ko. Sabi ko sa'yo, mag-start ka dun sa atom na negative usually. Kasi siya yung source ng electron mo in. Tapos hindi ka pwedeng tumalon ng yung parang 3 atoms away. Hindi pwede. Usually katabi niya lang talaga. Katabing atom or katabing bond.
Wait, kung pumunta dito, 5 na yung carbon.
Hindi. Oo. Correct. hindi ka pwede magbigay kay hydrogen.
Wala.
Ano na? So, I'll help you out with the first one.
Sa carbon mismo ilagay.
Pwede. Pwede nga sa mismo carbon. Ang mangyayari ganito, Josh. Pag ito, Josh, sige, tutulungan kita. Pag ito, Josh, binigay ko dito, what will happen to this carbon? Ito, kung carbon na nasa gitna. Hindi. Ayan, sige. I-drawing mo lang to. Ayan. Okay, go. Tama ba yan?
Hindi mo.
Kasi nga 5 na yung bonds ni carbon na to, no? So, ngayon, kailangan mag-give up ng bond ni carbon na yan. So, sino yung i-give up niya? Ito. Pag ito, ano mangyayari? Sige nga, i-drawing mo. Pag give up niya to, correct, mawawala yung metal group mo. So, mapuputol siya. So, hindi siya resonance. So, hindi mapupunta yan dito. Correct? So, sino yung... Sino yung next option mo? Ang next option mo ay itong double bond. Kasi double bond naman yan eh. What if itong bond na to, ibigay mo siya dito kay carbon lang? So, kapag ganyan, Josh, ano mangyayari? Ayan. Tapos, hindi. Gawin mo na yung gawin mo na yung ginawa ko. Ayan. Magre-resonance na siya. Tanggalin mo na yung arrow. Kasi wala naman ng what will happen to the double bond daw? Ito na yun, no? Yung mismong ginawa ko na. Okay, good. At may charge ba siya? May charge ba yan? Uy, nako. Tignan mo, ilang bonds yung carbon mo? Nasa left side na carbon. 3 bonds. Tapos may?
May lone pair.
May lone pair. Anong tawag dyan?
Negative.
Negative 1. Kaya tignan mo, tsaka balanse pa rin yan. Diba? May negative ka na oxygen. Overall, yung molecule mo ay negative. May negative din dapat dito. Anong tawag ulit sa carbon na to? Kaya nga pa ulit-ulit kong sinasabi yan eh. Carbon na may negative charge. Tapos 3 lang yung bonds niya. Kasi may lone pair siya. Anong tawag sa ano na yan? Sa carbon na yan, Josh?
Ano tawag sa carbon na yan? Yun po yung
Carbon ion.
carbon ion. Tatlo na po yung 5. Ang yung 3 lang.
Carbon ion yan ha. That's your carbon ion. O dahil dyan, tinulungan na kita dito sa unang example ko. O ikaw gumawa ng second example. Ako, sa second example, 2 ang nakikita kong resonance structures dyan. 2 pa, 2 more. Siyempre, yan yung una mo, resonance structure din yan. I can see 2 more. Gawan mo. Go ahead. Gawan mo siya ng resonance structure pa.
Dalawa. Okay.
So, may clue ka na, no? Kasi ang clue mo, sa negative charge nang gagaling yung resonance. Actually, yung electrons mo, no, sa resonance, nanggagaling ang mga electrons sa double bond at saka sa mga negative charges or negative sites mo, no? Okay, go ahead. Gawa mo siya ng resonance structure.
Range. Hanggang dito. Wait, 90 per minute. Hindi ko pwede ito. Ito mo ako ba tayo? Yan. Pwede dito. Posible. Okay.
Ay, hindi. Tapos na yan. Tapos na yan sa una. Number 2 tayo.
Kaya ko meron pa po eh. Kaya na-goal po ako.
Wala na yan. Okay na yung number 1. Sa number 2, I'm seeing 2 structures, resonance structures. Pero baka meron ka pa makitang isa. Or pangatlo, di ba?
Kaya po, I have 100 na ganun po. Siyempre, okay. So, siyempre, kung nandito, sa resonance structure na yun. I mean, obviously, pag may ganito po, siyempre. Wait a minute.
Tama. Pwede yun. Pwede yung direct na ganyan. Correct. Lilipat ngayon yung negative charge mo, no? Instead dun sa oxygen na nasa baba, ang negative charge this time will move to sa oxygen na nasa taas.
Ito po, pwede po.
Ano? Abomination. Grabe ka sa double bond hydrogen.
Pero meron po yata yun sa palladium.
Yeah. Inorganic inorganic hydrogen talaga. Siyempre sa organic hydrogen, laging 1 lang siya. What's your next one? Or what is the other, ano? Ang tawag dyan? The other resonance structure. Ang clue mo, medyo hawig niya yung 1, yung movement.
Kaya nga pa, inisip ko na po yan. Ang dami naman pala. Ano ayan po siya eh. Dami magka-plus dito.
Ang ayot pa rin.
Ang pala. Genus. Ito po yung tawag na genus moon. Magdadalawa pa rin. This is cursed. Maybe the other one was correct. No.
That's your answer na? Final answer? Mag-arrow pushing ka kasi. Saan nanggagaling yung mga arrows mo? Kunwari mag-start ka dyan sa pangalawa mo. Okay. Mag-start ka sa pangalawa mo. Sige, tama yan. Mag-start ka sa pangalawa mo. Pakita mo yung arrow pushing.
Too many charges is already suspicious.
Okay lang yan. Resonance structure lang naman ang hinihingi ko. Hindi ko naman sinabi na stable structure eh. Diba?
Okay. Kasi diba siguro naka-imprint na po sa utak kailangan stable for it to be a structure.
Tama naman yun. Pero makikita mo kasi sa mga mechanism, stability din naman yung hinahanap mo. Pero nilalagyan na kita ngayon ng parang idea na you can have those structures no as you are forming the products. Yeah, tama ito. So ito, arrow mo lang po, arrow pushing. So magdo-double bond to, then lipat dito. So may magiging positive ba tong carbon mo dito sa kabila? Josh? Yung carbon mo na nasa gitna.
Yun po yung carbocation.
Yung carbon na nasa gitna, magiging positive ba siya?
Opo.
Ilang bonds yan? Meron siya.
Meron po siyang 5 bonds.
5 bonds sa gitna? Oh.
Ay, 4 bonds din pala siya.
So dapat wala siyang charge.
It's already good actually. Wait.
That's correct.
You did not see that. So, ngayon, pwede pala maglagay ako ng 3-band oxygen. Wait lang. Kaya dito. Wala yun. Ay, baka may lone pair pa.
Ilan na yung carbon mo dyan? Namatay na yung carbon. Ilan na yung bonds ng carbon mo? Abomination. See, in organic chemistry, di ba parang sa Gen Chem, we are always reminded na carbon will only have 4 bonds. Same din sa organic chem. Pero minsan hindi mo talaga may iwasan na you will propose structures na beyond octet for carbon. Normal thing yan na nadadaanan mo siya.
Abomination in desperation.
Meron ka na sagot?
Wala po.
Pero mali mo, yan na lang din pala yung structure. Sige, try natin. Baka joke time lang din pala ako. No?
Hindi po yung sad.
Pag nag-stop share naman ako, babalik yan, di ba? Wait lang ha. Ang Diyos, ang aking pad ay nawala. Ayun. Oh, I'll stop sharing din muna. Balikan natin yung problem. Molecular shape na tayo. Yes. Ayun. Nandiyan siya. Ayan. There we go. Okay, and then let me share my whiteboard. Ayan. So, we can have your second one, no? Pwedeng ganito siya. Itong... Excuse po. Yeah. Negative 1. Formal charge. Okay, let's check. Pwedeng ganito, Josh, no? From the second one, itong lone pair na to, yan, itong lone pair na to, pwedeng ibigay niyo yan ulit dito. So, you'll have triple bond already sa oxygen, pero gigive up niya yung isa, bigay dito, and then bigay dito kay carbon. So you will have this CH2. Ayan. Then, isa na lang yan. Tapos ito, double bond. Then you still have hydrogen here. Carbon, this is still O, pero isang lone pair na lang. And then, magpa-5 bonds pala ito. Mukhang wala na. Mukhang hanggang dito lang siya.
Wala.
Ibig sabihin wala. Yung nakita ko ay kanina hindi siya pwede. Kasi 5 bonds eh. So, ibig sabihin hanggang dyan lang siya talaga. That's your resonance structures. Yeah. There's no other way that we can have the third one. Ay, namumura ko nga yung sa'yo. Kasi nga, ito, tingnan mo, Josh, magiging 5 ito. So, dito pa lang, limited ka na. So, yeah, the two resonance structures are these two. So, out ito. Okay? Hindi siya pwede. Huwag ka mag-alala. May marami pang mga resonance structures sa susunod na slides. Now, proceed with current slide. Tayo. Sharing. Okay. I'll now share my presentation again. So this time we'll now be moving with determining the molecular shape. So there are two variables so that we can determine the molecular structure of your compound. It's the bond angle and the bond length. So of course, bond length is just the how long your bond is. Bond angle is the angle between your 3 atoms connected by 2 bonds. So, syempre, 2 adjacent bonds iyan. So, bond length decreases across a row of the periodic table as the size of the atom decreases. Na-discuss na natin to last time, Josh. So, we have increasing bond length from oxygen to carbon, provided that they will be bonded to the same atom, let's say hydrogen. So, ang OH mo, siya ang may pinakamaikling bond length, followed by nitrogen-hydrogen bond, and carbon-hydrogen bond will have the longest bond length compared sa tatlo. While bond length increases down a column of the periodic table as the size of your atom increases. So let's say fluorine, chlorine, bromine. So as you go down the group, the HF, HCl, and HBr will increase. So sino ang may pinakamataas na bond length sa tatlo, Josh? Kung susundin natin yung trend, HF, HCl, HBr, sino ang largest atom? Chlorine, chlorine, bromine.
Si iodine? Saka sa bromine?
Correct. Iodine nga naman yung largest sa may astatin ka pa however. Pero dito sa tatlo, si bromine. So, since largest atom mo si bromine, siya yung magbibigay ng largest or longest bond length din. Okay? So, siya ngayon yung longest bond length. So, we can clearly see dito sa table, So, as you move from carbon, nitrogen, oxygen across a period, you are what? Ano nangyayari sa bond length, Josh? As you move across a period from left going to right. Carbon, nitrogen, oxygen. What happens to your bond? Okay, bond length decreases. Dito sa sa across a period. Down the group, what happens to your bond length? Chlorine, chlorine, bromine, and iodine. Down the group, Josh. Ano nangyayari? Again?
Luminit po yung bond length.
Across a group? Ay, down the group? Chlorine, chlorine, bromine, iodine?
Hindi ba po?
Hindi. Fluorine, chlorine, bromine, iodine. What happens to your H bond? HF, HCl, HBr, HI. Nag-i-increase, nagdi-decrease?
Nagdi-decrease po.
Bakit nagdi-decrease? From HAF down to HI. Nagdi-decrease. Give me an explanation. Bakit nagdi-decrease from HF down to HI?
Nagdi-decrease. Nag-lengthen siya kasi lumalayo po yung electrons.
Correct. Kasi lumalaki yung atom mo. Dapat baliktad ka. So we can clearly see here down the group what happens to your bond length.
Po siya.
Yan, down the group. From HF to HC, to HI.
61.
Okay, so bond length increases this time. So nag-i-increase siya. So this is pretty similar dun sa carbon mo, no? Carbon-chlorine bond, carbon-chlorine bond, carbon-bromide, carbon-bromine, carbon-iodine. As we can see here, bond length, yung bond length mo, nag-i-increase pa rin siya. Okay? Topic siguro kung digital pa. Anyway, so ito ngayon yung susunod, no? Yung molecular geometry, if you will recall, Josh, anong theory behind that?
Vesper.
Okay, the Vesper, no? And according to Vesper, anong meaning nun?
Vesper, valence shell, electron,
Pair.
P. Pair, tama. Pair, something. Something beginning with R.
Correct, that's correct.
Re something. Do, re, mi, fa, sol, la. Ganun po something.
Repulsion.
Repulsion, okay.
Theory. So anong sinasabi nung Vesper theory mo? Kasi siya yung magdidictate.
Cells repulse each other.
Okay, good.
Repulse each other. Repel each other.
Bonds lang ba ang nagre-repel with each other?
Yung mga electrons po mismo and electron pairs.
Okay, good. The lone pairs also are repelling one another. Sino yung may pinakamalaking repulsion? Let's say bond to bond, bond to lone pair, or lone pair sa lone pair. Sino ang may pinakamalaking repulsion?
Lone pair po sa lone pair.
Okay, naalala mo yun, di ba? Kasi ang lone pair, ang laki nung ino-occupy niyang space. That's the reason why the lone pair repulsion will be the greatest. No? So, kasi nga malaki masyado yung ino-occupy niyang space. So, ang susunod na repulsion natin ay lone pair sa bond. So, bond sa bond ang magiging weakest repulsion natin. So, kaya ang mangyayari, Josh, if you're obtaining lone pairs, what happens to your bonds? Pag dumadami, no, if you keep increasing the lone pairs, what happens to your bond angle? Yung lone pair mo, nag-i-increase sa central atom, ano nangyayari sa bond angle mo? Increase, decrease.
Dapat nag-decrease po.
Decrease, very good. Kasi nga, tinutulak ng lone pair mo yung mga bonds mo together. Sila yung magtatabi ngayon. Kasi nga, sila naman yung may weakest na repulsion. So, please take note. Bigyan kita ng summary ulit. Kapag dalawa lang yung, di ba may central atom ka, pag dalawang bonds lang, ano automatic ang shape? Wala kang lone pair. Dalawang bonds lang, Josh. Wala kang lone pair. May central atom ka.
Lumiliit po siya yung parang from methane to ammonia tapos po.
Hindi, tama yun. Ano na tayo, nasa mga molecules na tayo. Central atom, tapos ganyan. Walang lone pair sa gitna. Anong shape yan?
Walang lone pair. Tetrahedral po.
Tetrahedral, 2 bonds lang. 2 bonds lang. 2 bonds, walang lone pair sa gitna. What will be the geometry?
Bent.
How come bent yan?
Two bonds linear, na wala pong lone pair.
Oo, walang lone pair sa gitna. That's linear. Ang band angle mo, 180. Kapag tatlo siya, 120, trigonal planar. Kapag apat, 109.5. Paano pag lima? Bihira kasi yun sa sa organic compounds. Usually, hanggang tetrahedral lang.
Trigonal bipyramidal.
And what are the band angles for trigonal bipyramidal? Ideal? 120 and 90. Good. So, ayan, ito ay mga linear molecules. Example nito ay yung alkenes, no? Ang alkenes ay triple bond carbon yun. So, 180 siya dun sa bawat side, no? Carbon to hydrogen, then carbon to another hydrogen. So, the ball and stick model will be looking like this. It's a linear molecule. So, kapag trigonal planar, you know this already, ha? So, mga may double bond naman. So automatic, Josh, kapag ang carbon mo ay may triple bond, ano dapat ang shape? Pag carbon triple bond, Josh, ano dapat ang shape? Automatic linear siya. That's a linear molecule already. Pag ang carbon mo naman ay may double bond, ano dapat ang shape? Automatic.
Linear din.
Carbon double bond. Double bond lang siya.
Hindi ba po siya linear? Trigonal planar.
Okay, this is trigonal planar. Tapos, kapag apat ang bonds, of course, that will be a tetrahedral arrangement. So, bakit hindi kaya square planar? No?
I don't know, because maybe ayaw po ng Diyos.
O hindi, sagutin mo yan ng maayos. Bakit hindi na lang yung, kunwari, methane. Wala tayong square planar na methane. Di ba?
Baka siguro it will arrange po to, wala naman po lone pair on top eh.
Oo nga, pero bakit preferred natin yung 109.5 degrees kaysa sa 90 degrees?
Is larger, yung 109.5
Very good.
degrees.
The 109.5 degrees kasi maximizes the separation between your bonds. That's the reason why it will be your tetrahedral, the natural tetrahedral arrangement, not the square planar. Kasi sa square planar, 90 degrees separation lang sila. Unlike for the tetrahedral arrangement, it's 109.5 degrees. So we are maximizing the separation ng mga bonds mo. Okay? So, bago tayo bumalik dyan, or umalis dyan, meron ba dito mga hybridization? Teka lang. Meron ding hybridization sa next na part ba siya? Okay? So, Josh, kapag nagda-drawing ulit tayo, pag solid line, ano meaning nun? Pag solid line?
Like right on the page po.
Okay, kapag broken lines or dash line, kapag wedge,
kapag wedge, going outside, pointing.
Yeah. Pointing in front of you, no? So, papunta sa'yo. So, usually, yun yung meaning ng wedge. So, this is the ball and the three-dimensional structure of methane, no? So, it's quite hard for us to represent organic structures in paper. That's the reason why meron tayong wedge and dash line, no? Dahil ang mga molecules mo ay 3D because we are 3D, di ba? Because humans are made up from molecules. And dahil three-dimensional tayo, three-dimensional din dapat ang molecules natin. Okay? So, this is the ball and stick model for methane. So, next. However, yung methane mo, Josh, pwede rin naman siyang i-drawing ng ganito, no? So, the molecule can be turned in many different ways, generating equivalent representations. So, all of the following are acceptable drawings for CH4. May question ako, Josh. Mga resonance ba ito ni methane? Tingnan mo yung drawing ng methane.
Exact same thing.
Okay. These are same compounds, no? And you don't have delocalization ng electrons. Kasi sa resonance naman, ang halaga ay delocalization ng electrons. Wala ka naman delocalization na nangyayari. So therefore, these are just the same molecule. So, binago lang natin, iniikot lang natin yung methane, no? So, Josh, ha, tignan mo to ha, kasi ito yung usual way na sinusulat natin yung methane. Pero you can also draw methane like this, no? Yung parang may sungay siya. Parang ganito yan, Josh. Ganito, taas nakaganyan. So, hindi ko lang alam kung ano, nagbe-make sense siya sa'yo. Nakaganito, tapos may parang bunteng, nakaganyan siya. That's still trigonal, tetrahedral. Okay? And then, note that wedges and dashes are used for groups, no, that are really aligned or one behind another. So, it does not matter.
Pwede rin
Yes.
po ba kaya yung ano po yan, yung parang, yung gano'n na parang circle tapos yung nakagano'n.
Pwede kaya, parang ganun siya. Ito, tapos ganun. Okay. Pag nagdo-drawing ka ng wedge and dash, hindi naman nagma-matter kung nasa left or right yung ano mo ng atom mo. Okay? Ngayon, ang tanong dito, Josh, paano natin dinodrawing yung mga lone pairs, no? So, a non-bonded pair of electrons is counted as a group. So, kinakount din natin siya as a group. So, Joshua, very important sa organic chemistry na din nilalagay mo yung lone pair, especially for oxygen, nitrogen, at kung may lone pair yung carbon mo. Yung halogen mo, sige, pwede na rin natin lagyan. Pero usually kasi, ang halogens, ilang bonds siya, Josh? Ang halogens. Usually.
One lang po siya. So, parang siyang hydrogen din.
Okay, chlorine, chlorine, bromine, iodine. Usually, chlorine, chlorine, bromine, iodine. They will usually have one bond lang sa organic chem. So therefore, para siyang hydrogen. Kaya minsan, hindi na namin pinapakita yung lone pairs niya. Di ba, kunwari pag binaband natin si chlorine, let's say chlorine, ang totoong chlorine ay ganito. Di ba? 3 lone pairs, then 1 bond. Minsan, nagiging ganyan na lang siya. Matik yan, alam natin na si chlorine will have additional 3 lone pairs. Ha? Pero for nitrogens, nitrogen atoms, oxygen atoms, very important na nilalagyan mo siya ng lone pair. So, example, your ammonia, of course, it's, ano, di ba? Ammonia, anong shape ni ammonia?
Yung trigonal pyramidal.
Okay, good. Trigonal pyramidal. However, its electron domain is what?
Electron
Ano yung
domain?
electron?
Apat.
Apat. So, it's a you have a lone pair on top. So therefore, the electron domain of ammonia is what?
Four nga po yung electron domain.
The electron domain is, anong electron domain ni ammonia? It's still
Apat po. 4.
Tetrahedral. Correct, 4. Tetrahedral siya.
It's the same po.
Diba, pag electron domain, yun yung binibilang mo kasama yung lone pair. Because we count lone pair as group din, no? As a group. So, yung lone pair natin, as a group pa rin siya. So, parang nangyayari kasi dito, we are deriving shapes out from the basic shapes, no? Kasi basic shape yan si tetrahedral, eh. If we convert one bond into lone pair, magiging trigonal pyramid siya. Pag dalawa na yung na-convert into lone pairs, ano mangyayari? 2 bonds, naging lone pairs na siya. What will happen to your... Okay, bent siya. Pero they're all derived from tetrahedral. So the molecular shape is referred to as trigonal pyramid for ammonia this time. So for water, ayan, nasabi na natin siya, no? The electron domain is still tetrahedral or tetrahedron. Pwede din yun, no? Tetrahedral. Kasi you have 2 lone pairs and 2 bonds. However, the molecular shape is bent. So, nako ha, pakitandaan ko, Josh. May tanong ako, sa hybridization, ano yung tinitignan mo, Josh? Yung shape or yung electron domain? Sa hybridization. Naalala mo to?
Opo.
Anong tinitignan natin sa hybridization? The electron domain or the molecular shape?
Electron domain.
Okay, the electron domain. Sinasama natin yung lone pairs. Kasi babalikan natin yan. So, ngayon, what happens to your bond angle kapag nagkakaroon ka ng lone pair? Kunwari, from tetrahedral to trigonal pyramidal to bent. What happens to your bond angle? Increase, decrease. So, kunwari, methane, ammonia, water. Ano nangyayari sa bond angle nila? Anong bond angle nila?
Palit na palit po.
Bakit? That's correct. That's true. So the bond angle from methane to ammonia to water, it's decreasing. Why? What is the reason?
Kasi napupush na po siya more, yung electron pairs push more than yung bonds.
The electron pairs are, anong electron pairs ito? Kasi bond at lone pair ang pwedeng electron pair eh.
Naano po siya, napupush inward.
Sino nagpo-push inward? At sino yung nagpo-push?
Napupush po yung bond angle.
Yung bonds ay napupush inward. Nino? Sino nagpo-push? So, correct yun. The bonds are being pushed by what? Kaya siya lumiliit, no? So, the bonds are being pushed by what?
The bonds are being pushed by lone pairs nga po. Dalawa po lone pair yung water.
Okay, correct. Due to repulsion. So, due to lone pair repulsion, no? So, yung bonds mo ngayon, lumiliit siya. So, since sabi ko nga sa'yo, di ba? The lone pair to lone pair repulsion will be the greatest. So, if you have two lone pairs in water, these two lone pairs will try to maximize their orientation so that they will be separated from one another. However, nagiging collateral damage mo or nako-compromise mo ngayon yung bond angle. So the bonds this time, they are being pushed together. So that's the reason why you'll have a smaller bond angle for water having two lone pairs, and then you'll also have a smaller bond angle for ammonia kasi may isa ka pang lone pair compared to your methane without lone pairs at all. So tetrahedral siya. The perfect bond angle, 109.5 degrees. So the bonded atoms are compressed into a smaller space with a smaller bond angle due to this repulsion. So ayan na ngayon yung mga example, no? So linear, trigonal, planar, tetrahedral. Sa organic chemistry, Josh, pag tetrahedral, what can you say about the carbon atom? Pag tetrahedral siya, ang bond angle mo ay 109.5. Dapat yung carbon mo ay...
Okay na po.
Okay nga, 109.5. 4 bonds, yun yung mahalaga. 4 bonds siya. Lahat single bond. Lahat single bond ha. Paano kapag ang carbon mo ay trigonal planar? Kailan magiging trigonal planar ang carbon? Kapag may?
3 bonds po.
Hindi siya 3 bonds, 3 groups.
3 groups. Doesn't matter kung ano bonds.
Pero usually, ano yung bond mo ni carbon? Para maging trigonal planar. Hindi yan kahit ano.
Trigonal planar. Double bond po.
Correct. Kapag may double bond ka, dun ka magkakaroon ng trigonal planar. Then this time, linear. Kailan magiging linear ang carbon mo?
Linear. Pag talagang may parang acetylene? Ay, hindi.
That's an example, acetylene. Pero in a general sense, when will your carbon becomes a linear carbon? If you have a triple bond. Yun yung pattern. Tetrahedral, all carbon will have all single bonds. Trigonal planar, your carbon will have one double bond. That's 120 degrees. And then linear, your carbon will now have a triple bond. The bond angle is 180. So ang example nun ay methane, ethylene, acetylene. Okay? So ano yan? For tetrahedral, trigonal, planar, and linear respectively. So, ang susunod natin na lesson, Josh, ay drawing structures, no? So, meron tayong tinatawag na, ayan, para, ayan, dapat dito tayo matatapos ha, kasi madami pa namang slides to for drawing structures. Drawing organic molecules. Para kapag nag-drawing kasi ako sa anakin ng structure, kunwari ng aniline, alam mo na yung parang shortcut nun, no? So, aniline, kung ano mga organic compounds, alam mo na siya. So, we have this thing called condensed structure. So, yung una is this one, the general form, no? The long form, kumbaga. So, kapag condensed structure, Josh, all atoms are drawn in, but the two electron band lines are generally omitted. So, katulad nito, Josh. Ngayon. Atoms are usually drawn next to the atoms to which they are bonded. And finally, parentheses are used around similar groups bonded to the same atom. Example nito. So, how many carbons for this example letter A, Josh? How many carbon atoms, Josh, for example A?
Yung 4.
Okay, 4. Tapos, sa first carbon mo, Josh, how many hydrogen atoms?
1, 2, 3,
That's
4,
carbon
5, 6, 10.
Carbon 1 lang, carbon 1.
Carbon 1, 3, 2, 2,
Okay,
3.
correct. So magiging ang pattern ay CH3, CH2, CH2, CH3. Can we still condense this one? Makakondense mo pa ba to?
No.
Yes, makakondense mo pa yan. Kasi yung nasa gitna mo ay pareha CH2, right? So this 2CH2 can be condensed into this. Kaya ang condensed structure ng butane ay CH3, open parenthesis, CH2, close parenthesis, 2CH3. That's your butane. How about for letter B? For letter B.
CH3, 3, CH.
So, nasaan tong CH? Pakituro nga yan dito sa structure mo.
Could be in the first po. Or, kinondense na po siya
hindi
talaga.
yan sa first. Naku, tignan mo. Hindi impossible maging first yan, yung CH. Nasaan ang CH?
Huli po siya.
Paano siya magiging huli? Kung puhuli mo siya, ano yun? CH lang yun. So, let's say nakaband siya. Kulang siya ng 2 bonds. Diba? Nasaan yung CH mo? Sige, i-drawing mo or in-circle mo. Mag-annotate ka na lang. Where is your CH for your example B? Okay, good. Yan ngayon yung CH mo, no? So, yan yung mo, trimethyl. Trimethyl propane yan. 1, 2, 3, longest, yes. Lone pairs are also omitted when you write condensed structures. So,
why do you omit them po? Why can't you just put them on there? Parang ganito po.
Pwede rin naman. Actually, minsan ako, naglalagay pa rin ako ng lone pair kahit naka-condensed structure siya. Pwede naman siya. Ako nga naglalagay. Lalo na pag nagpapakita ng reaction mechanism, it's very important na may mga lone pairs. So, you can also have this one, no? Bibigay ko na yung mga term dito, Josh. Sa example letter A natin, Josh, can you find the longest chain? Yan. I-encircle mo yung longest chain sa example A, Josh.
Longest chain?
Yeah. Hindi. Dun sa sige, pwede rin naman dyan. Tapos, ang tawag dyan sa longest chain ay parent chain. Kasi kapag sinabi ko sa'yo, what's the parent chain? Ganyan, ganyan. That's your parent chain. Ngayon, di ba parang may nakasabit na CH3? Tama? Sa pang ilang carbon yun? Sa pang ilang carbon?
Para po siyang tumor.
Yeah, it's like a branch, kumbaga. Ganun na lang, branch. Pero pang ilang carbon siya, para marunong ka na rin mag-indicate. Sa pang ilang carbon siya, Josh, nakakabit. Starting from the left.
CH3. CH2, CH2. So hindi na po siya pwede i-condense pag may ganito po sa gitna.
So sa third carbon siya nakakabit. Okay? Starting from the left, hindi pa muna tayo mag-name ha, para lang meron lang tayong location. So, ang tawag dito sa CH3 na to ay, anong tawag kaya dyan, Josh? Tingin mo. It's not a tumor. It's not a tumor.
Ito, how I imagine it po.
It's a...
may ganun.
Yeah, this is a... Letter S ang start.
It's syndrome?
No. Substituent. Ganun yan. May parent chain ka, tapos may substituent. Okay? So, and this is another way to write condensed structure no, kapag may substituent. So, lalagay mo sa open and close parenthesis yung substituent. Kapag may double bond naman, you keep the double bond. Josh, kapag may multiple bonds ka, double bond, triple bond, you need to see that in your condensed structure. Sige nga, example tayo. Ito, Josh. Paano mo to i-condense? C, H, H, then H, then C, then H, COH, tapos another H, then another C, H, H, H. Ayan, pakisulat nga yung condensed structure niyan, Josh. Sulat mo na lang through your digital pad.
2-methyl propanol?
Yeah, that's 2-methyl propanol, correct.
I named it.
Okay, good. Okay, good. That's your condensed structure. How about the third? Ito, yung third one. This is dalawang chlorine. Hydrogen tong nasa ilalim na. Then another carbon na may hydrogen. This is another hydrogen. And this is oxygen. Tapos C, CH3, then CH3, then another CH3. Ayan. Go ahead, Josh. Pakisulat yung condensed structure ng number 2. Example 2. Yung nasa ilalim ng unang carbon, HA siya. Yung sa dulong carbon, yung nasa rightmost, that's CH3.
Ether po?
Yeah, that's an ether. Very good. ROR. Pero hindi na lang siya simple ether, no? Kasi meron kang halide.
Ano ba mauna po?
Ay, hindi ko alam sa'yo. Sino ba yung nasa outermost? Hindi, si L2. Si L2 ang mauna. Kasi siya yung nasa labas eh. Kung titignan mo. Hindi. Si L2 ang nasa dulo. Aya. Hindi. Si L2 yung nasa dulo. Pwedeng si L2 yung nasa dulo. Kasi matic naman yun. Automatic naman, Josh. Hindi. No, right. Nasa leftmost. CL2. Kasi automatic naman, we know that CL2 will be bonded to that carbon. Correct?
What is this one? Is this so cursed?
No, it's not cursed. It's just a simple ether pa.
What?
Ano yan? 1, 2. 2,2-dichloro ethoxy, third butyl, 1, 2, 3. Third butane. Yeah. Uy, okay. CCH33. Correct. That is the condensed form. Very good. Next. Puro structure lang tayo ngayon, ha? So, paano kapag ang structure mo daw ay may C-double bond O? So, kapag may C-double bond O, depende yan dun sa nakikita mo. So, let's say, Josh, eto ano nga ulit to, Josh? Kasi alam mo naman na yung mga functional group eh. What functional group is this? C-double bond OH. What functional group is this?
Aldehyde?
Yes, aldehyde. So, cho yan. Basta makikita mo yung CHO, aldehyde agad yan. Basta ang aldehyde. Tapos, kapag ketone, so CO lang siya, no? Ayun, may CO ka. If you have CO, Josh, automatic ketone ito. What can you say about the condensed structure of C-double bond O? Hindi mo pinapakita yung double bond O. Automatic na lang, Josh, na, okay, if it's a carbon, and then meron kang kasunod na oxygen, and then that will be bonded to another carbon ulit, automatic, Josh, that will be a carbonyl group. So, by the way, carbonyl pala ang tawag dito.
Carbonyl. So, ano po yan? Ketone?
Ketone ito. Ito, how about this one? How about this one? Lagi mo yan nakikita. Carbo. Ano may mapapansin mo? COOH.
Carboxylic acid mo.
Very good. This is carboxylic acid. How about the last one? Hindi ko lang alam kung familiar ka na dito. COO tapos another alkyl group. So magiging CO2 lang siya. CO2 then sulat mo lang yung niya, condensed structure. Tingin mo, alam mo na ba to? So in this example, the only way for all atoms to have an octet is by having a carbon-oxygen double bond. Tingin mo, anong mo dyan? Anong pangalan? Anong group kaya yan? Tingin mo, anong functional group?
I don't know.
Okay, so far, that is an ester.
Ester, okay.
Ester ang tawag ngayon dyan. Okay. Tapusin lang natin itong mga structures. Yan. Pag lang ako, baka mag-overtime ako ng 5 minutes lang. So, ngayon, tignan mo ha. Ang susunod na ngayon na ibibigay ko, Josh, ay tinatawag na skeletal structure. Kapag skeletal structure, Josh, sige, kapag skeletal structure, what can you say about the skeletal structure?
Every H around yung carbon is
removed.
Omitted.
Okay, omitted. So, correct. So, hydrogens will now be omitted. Tapos, instead na sa condensed structure, no, nakikita mo pa yung pinaka-formula, CH3, CH2, CH2. Sa skeletal, hindi na talaga. Yung bawat vertex or dot dun sa skeletal structure ay nire-represent ng Josh? Yung bawat vertex.
Bawat vertex. Dapat parang dalawa or one. How much it could possibly have? CH3, CH2, or CH?
Hindi, yung bawat dot dyan, bawat vertex sa skeletal structure mo, it represents what? Carbon. And then, let's say itong carbon na to, Josh, ito, yung ni-red, nalagyan ko ng mark. Ilang bonds siya? Ilang bonds meron yan?
3. Tapos ang dalawa po yun dyan.
Ha? Ulit?
Dalawa po.
Itong carbon 2. Carbon 2 ha, starting from the leftmost. How
Two.
how many bonds?
Two po.
Two what specific bond?
Hydrogen.
Two hydrogen bonds. Dapat, actually, ang total bonds niya, Josh, ay 4 pa rin. Dalawang hydrogen bonds and dalawang carbon bonds. Ngayon, pag carbon-carbon bond, we are drawing it, no? Pinapakita pa yan sa skeletal structure. Ang nawawala sa skeletal structure, yung carbon-hydrogen bond. Okay? So, ngayon, katulad nito, yung skeletal structure ni cyclohexane. No? So, we will now see like a hexagon na lang without the hydrogen atoms anymore. So, please take note, Joshua, we are also indicating the carbon-carbon bonds sa skeletal structures. So, ito yung interpretation. Alam mo naman na ito, no? Alam mo na kung paano ito i-interpret. Pero, puntahan mo yung number 3. Ito, yung step 3. So, kapag may step 3 daw, mag-a-add ka ng lone pair sa important atoms. Saan ka mag-a-add ng lone pairs? Nitrogen and oxygen usually. Okay?
Well,
So
di ba
kapag
po
mga...
sa mga carbon?
Sa carbon din, syempre, lalo kapag carbon ion. So, syempre, pero sa halogens, kahit wala na. Pero sa ngayon, sanayin natin na meron kang lone pair sa halogens mo. Can you draw the skeletal structure for this one? Ito. Okay, dito mo ilagay. So you draw the skeletal structure for that one. So, yun, mag-start ka lang dito sa carbon na to. 1, 2, 3, 4, 5, 6. Okay. Okay. Okay, good. Meron ka pang kulang sa oxygen na nasa OH. Lone pair. No? Pero minsan nga hindi na namin nilalagyan. Ito yon, di ba? So, we're actually, ayan, that's correct, no? So, ang mastery mo dapat dito, Josh, you can write the skeletal structure and you can go back dun sa complete structure niya, no? Dun sa may carbon-hydrogen bonds, no? These are other additional examples, no? So, sa ano natin, sa whiteboard natin later, ikaw yung mag-solve ng mga yan. Ikaw na mag-share ng whiteboard mo para at least masasave mo yung image later. So, ano masasabi mo dun sa sa triple bond? Tignan mo nga, Josh, sa triple bond. Anong niya, representation? Tignan mo sa triple bond. Linear dapat siya, ha? Linear yan, Josh. So, paano kapag acetylene lang? Sige nga, i-drawing mo nga, Josh, yung acetylene, skeletal structure niya. Hindi yan acetylene. Actually, yan drawing mo. Ito yun. Acetylene. Oo, hindi. Acetylene yan. Acetylene ba yung ethylene? Hindi, ethylene yan. Acetylene, triple bond.
Ethylene yata po acetylene. Ethylene yata po yan.
Ethyl ng acetylene. Nga, acetylene. Acetylene pinapadrawing ko sa'yo. Paano mo ito-drawing?
Acetylene.
Technically, ganito dapat ang acetylene.
Ethyl nga.
Ganyan lang. Ethyl.
Wala pong ganon?
Wala na, kasi hydrogen naman yung ikakabit mo no? Di ba? Pero sa amin madalas, ginagawa namin, ginaganyan namin siya. So, automatic kasi, yes, to indicate na may hydrogen pareha sa both sides, no? So, that will be acetylene. Kasi Josh, yung drawing mo kanina, yung ganito, this is not acetylene. Anong itsura niyan? Ito ang equivalent niyan. Kasi may dot ka Diba? Ano, vertex to, vertex to. That's CH3 for us. So, ito ngayon yung equivalent niyan. Meron pa ba? So, ayan. Paano kapag mayroong charge yung carbon mo, no? So, kapag may charge yung carbon mo, kung ano yung charge, itatapat mo lang dun sa vertex. No? So, a charge on a carbon takes the place of one hydrogen atom. So, therefore, if you have a charge here, Josh, let's say ito, itong sa cyclohexane, how many bonds na lang ang meron itong carbon na to? How many CH bonds, kumbaga?
Yung ano po, yung mga, yung kung malapit po yung mga vertices.
Ano malapit yung word? Example?
Super lapit po yung sa skeletal structure. Parang,
Hindi.
parang,
Ang pangit mo mag-drawing pa ganun. Hindi ka pwede maging organic chemist. Kailangan represented ng maayos. Ano yan? Bicyclo. Bicycloalkanes. Iba pa yan. Ibang usapan yan. Pero pwede rin natin i-drawing yan.
ito po. Mga ganun.
Meron yan. May mga ganyan. Bicyclo.
How will you know po which na carbon po is being which carbon po yung natukoy?
Matatrace mo naman siya based dun sa drawing. Anyway, ayan. Uy, balik tayo sa tanong ko, Josh. How many carbon-hydrogen bonds for this carbon? Yung may plus. Supposed to be ito, kunwari ayan, yung nasa left muna. How many carbon-hydrogen bonds, Josh? Kasi hindi na pinapakita eh. How many CH bonds for this one? 2. Pero paano kapag may positive? Yung nasa right ngayon. Kasi carbocation yan eh. Ano meaning ngayon kapag may positive na siya? Ilan na lang? Ilan na lang ang carbon hydrogen ko?
Tatlo lang
Again?
po.
Ilan?
3 lang. 3.
Tatlo? You have additional 3, edi 5 bonds na yan. Diba? Kasi may CC bonds ka na dalawa dyan eh, based sa positive.
Magiging 3 nga po siya na bonds.
Isa na lang na carbon-hydrogen bond. Yun yung nililinaw ko ha. Kapag meron kang positive, you subtract 1 hydrogen bond. Yes. You subtract 1 carbon-hydrogen bond. So that's actually similar with your carbon ion, no? So for carbon ion, you still have a negative charge there. Tapos, may carbon-hydrogen bond na isa na lang. Pero, usually ganito namin siya nire-represent. Ako personally, Josh, kunwari may carbon ion ako dito. Nilalagyan ko siya ng lone pair, tapos negative. Yan, ganyan siya. Okay? So, you can also show the carbon-hydrogen bond, no? Yung nag-iisa. Tapos, ganyan. Tapos, negative. Either representations will do. So, paano kapag the skeletal structures ay may mga lone pairs, no? Usually, yung lone pairs, pinapakita namin din siya sa heteroatoms. Ang tawag namin sa mga oxygen, nitrogen, fluorine, chlorine, halogens, heteroatoms ang tawag doon. Joshua, sulfur yan, heteroatoms yan, heteroatomic organic compounds. Because you are adding, aside from carbon and hydrogen, you're adding oxygen, nitrogen, phosphorus, sulfur, etc. and the halogens. So you can write alcohols this way, may OH ka. Pero you can also indicate the lone pair. So, and 2 lone pairs for alcohols. Kasi nga, derivative lang din sila ni water. Eh. Derivative yan ng water, yung alcohols. So, it's very important as well to show, kunwari may oxonium ion ka. So, pag oxonium ion, how many bonds, Josh? Yung oxonium ions? Surrounding oxygen?
Anong sibo yung oxonium?
Oxonium. What is oxonium ion? Yun yung tinatanong ko nga.
I really don't know.
Yeah, oxygen is surrounded by how many bonds?
By 3.
3 bonds. At ano ang magiging
So
charge ni
hydrogen
oxygen?
naman ito. yung kasi. So
Oh
parang
yeah,
hydrogen.
oxonium, hydronium, di ba? At ano magiging charge ni oxygen? Anong magiging charge ni oxygen, Josh? Sa oxonium
Um,
ion?
ah, wait lang. -3 po.
Ano negative 3?
Oxonium. Yung
Oo.
ion po na
Oo,
tatlong bonds lang.
tatlong bonds ng oxygen.
With ano po? Hydrogen?
Hindi, regardless. Kung ano yan. Kung kunwari ganito, oh. Ayan, oh. Iisa na lang yung
Hmm.
lone pair mo.
Ah, ah.
Anong charge dyan ni oxygen? Tingnan natin. O, compute natin formal charge. 6 minus 3 minus 2.
1. Okay. 1 plus.
Kaya positive 1 yan. Okay? Oxonium ion is always positive 1. Remember that. I'll stop sharing. Ikaw ngayon mag-share. Dito tayo mag-e-end. Bibigyan kita ng dalawang problems. Then give me the skeletal structure.
This is nice.
Really? I'll annotate na ha. Yung sa una, I'll give the complete structure. Then, give me the skeletal. Sa pangalawa, I'll give the skeletal, give me the complete structure. Para lang masanay ka magsulat. Let's say you have your carbon. Ito ang complete structure ha.
Why does it look so bad?
Not sure if it looks so bad.
It looks strange. What is this? Kumaga mo, please write the skeletal structure of this protein.
Don't worry. Uy, ang ikli pa nga lang nito eh. Ito na, last na to. Okay, ayan. Ayan muna. Give me the skeletal structure. Ayan, mabilis lang sa'yo dapat yan. Sa baba mo na ilagay. You write it below the structure. Ayan. Para
Okay,
masusundan
so,
mo siya. Very good.
pwede pong circle.
No, hindi naman benzene yan. It's not
Dito
benzene.
po sa bed. Dito po sa benzene.
Mm-hmm. Okay, good.
I think I'm pretty good at this. Or am I?
Yeah, you're good. Dapat lang you're good. Kasi madali lang yan. Okay. Good. That's correct.
Natakot
Okay.
po ako sa mga pumangit.
Okay, good.
Ito po mabasa yung mga ibang skeletal structures
So,
na
at that part, what is the functional group? Ang cute, no? Alam mo yung emoji na ganito, Josh. The ethyl ether.
the
Okay, good.
ethylene.
Ayan, straight pa rin yan. Linear kasi siya. Huwag mo kakalimutan yan. Okay, good. Oh, hindi yan straight. Nagmukha lang straight yan sa akin. Kasi trigonal planar na yan, di ba? Pag double bond. Yan, good. Yan. Yan ang tamang representation. Good. Okay, good. Mali. Bent yan. Kasi dalawa ang lone pair mo kay sulfur eh. I have a question, Josh. Pag ROR, anong tawag mo? Pag ROR? Ito, ano nga to? Anong functional group?
Ether mo.
Ether. Ayan, no, tignan mo. Pinalitan ko yung oxygen ng sulfur. Parang ganyan siya. Anong tawag mo ngayon dyan?
Ether mo.
Ha?
Tayo ether.
Tayo ether. Very good. This is tayo ether. Oh, you don't show
sinunod ko
carbon.
sa carbon. Nalagay ko po sana CH.
Okay, yeah, that is the structure. This is correct. Oh, next page mo. Kasi
Yung
ako
mga
naman magdodrawing ng skeleton.
skeletal structures ng mga parang
Oh,
mga
ako naman magdodrawing ng skeleton. Ikaw, ang ibibigay mo complete structure ha. Give me the complete structure for this.
oh no.
Mabait pa nga pinakita ko pa yung ano dyan. Sa iba yan, hindi na yan. As SO3H lang yan sa iba. Dire-diretsong SO3H. Ako pinakita ko pang OSO2H. Ano pa nga ito? Ayan, okay na yan. Give me the complete structure. And then we'll end with this one.
Yung like complete mo.
Yeah. Lahat, papakita mo. Lahat ng bonds.
Ay,
Uy, asan yun? Mag-start ka sa carbon. Ay, masisikipan ka. Ibaba mo yan.
genius. Mga ano pa mga secret ways.
You're not sure. You always count the number of bonds for carbon. Abominations.
Munti ka na po na mag-belt yung yan.
Cyanide, oo.
Pero yung cyanide po, diba nakalabas po yung mga cyanide.
Mm-hmm.
O2H po or ano, meron po secret po doon?
Ilan yung, ayan, good. Tama.
Carboxylic. Ano
Hindi,
po tawag po?
may hydrogen ka pa. Sulfonic acid. Hindi, may hydrogen ka pa, Josh. Sorry. Tama. Tama yan. Okay na yan.
So parang carboxylic pero sulfonic. Hindi mo po parang may ano dyan, yung mga sulfonic. Toxic mo po sila or explosive or ano doon eh.
Yeah, At saka ano yan ang mga sobrang acidic na mga yan. Sulfonic acid, nag-shutdown yan ng mata eh. Nitronium ion, mga sulfonic acid. Wala pa yung mga hydrogen mo dyan, ha? Very good, no? Ang technique mo ay dinodrawing mo muna yung mga carbon, no? Then you'll just add yung hydrogen. Okay.
Grabe po. Sir, ito po yung ano po, subject po.
No. Next time yan. Mali yan. Actually, mali yung ginagawa mo sa benzene. Matic yan na naka-plane lang. Kasi trigonal plane na yan. Flat ang benzene ring, di ba?
Ano po to? So, magaganon po sila.
Yeah. Alam mo ba sa instrument, pwedeng mag-interact yung hydrogen tsaka another hydrogen.
So may bago pong
Magkapit-back.
hydrogen squared. Hydrogen squared po.
No. Kasi 'di ba magkalapit sila by space. Pwede rin naman kasi Josh yung isa ay ganito, no? Yung hydrogen na nakadikit dun sa double bond. Pwedeng naka-in front sa atin or naka-back din. Or pwede rin ganyan. Kasing flat sila nung magka-plane sila ni benzene ring. Oh, you're not yet through. Uy, tsaka yung bond mo dun sa carbon double bond o nitrogen. Abomination.
Hindi ko po yung sulfonic, ganun po.
Yeah, dapat nga sulfonic. SO3H yan. Baguhin ko na SO3H. Yup. Sige, para sulfonic acid na. Pero pwede rin yun, sulfite. Parang may sulfite na nakakabit sa benzene.
Pwede po kayang ganun po.
Hindi. No.
Alam po, may proposition. Ganun na lang po.
Eh di yung na lang, yung O tsaka yung OH yung i-bend.
Ito po,
I-wedge. No. Yung O,
pwede po.
siya ang ang i-wedge at saka nasa same plane yan. Okay, it's up to you. Bahala ka. Nitrogen. Carbon double bond O nitrogen. Tignan mo yung bonds.
Yun. Yan po yung tama dapat. Pang ganun. Nitrogen. Okay, tama?
No, the carbon double bond O, then nitrogen. This part. Ano yun? Ayan, bilangin mo. Abomination.
Bakit ka double bond? Nalagay ko ba
I
double
don't
bond?
know. Okay, good.
Hindi ba po may something else dito?
Wala. Dalawang bonds lang. Oh, hindi. Paano kapag hindi pinapakita yung bond? Ano meaning nun? Nag-iisip ka. Ay, nako. Nag-iisip ka ng OA. Hindi. Anong ilalagay mo dyan? Another hydrogen. Correct. Para kung gusto mo gusto mo ng thrill, pwede nga yun yung ginawa mo. Ganito. O, ayan, nilagyan ko siya ng negative dito, Josh. O, ayan, ganyan na lang.
No.
Tama naman yun. Tama pa rin yun. Ganyan pa rin siya. Okay. And then, Okay, that's your aldehyde. Pero however, meron kang carbanion. Pwede dyan sa ilalim, Josh. Okay, you can place the lone pair there. No, lone pair na. Okay, good. Then negative. Good. Ayan. Yeah, that's the complete structure of that molecule. Imagine, no,
Hindi po
Josh,
doctors mo.
as long as you are following the octet rule for carbon and you are following the functionalities, no, you can create as many as you can na organic compounds. Like this, no? Ayan, organic compound na yan kagad. So, we're not really sure kung ano na yan, na-synthesize na yan or what, no? Kasi sa sobrang dami ng organic molecules, we don't know if someone already synthesized that one or not. Okay? Pero feeling ko may mga nakagawa na ng ganyan or very near sa ganyan. Medyo mahirap din kasi synthesis yung pagkasama-sabayan mo yung mga organic functionalities, no? So, next meeting, Josh, will proceed with, sa Tuesday pala, Josh, ha? Yan, balik lang ako. I'll stop sharing na muna. Ayan. Next meeting, Josh, sa organic. Sa Tuesday, Josh, balikan natin yung Anachem natin. So, hopefully, we'll finish Anachem on Tuesday. And Thursday, no? Tuesday, Thursday, we'll have Anachem 4. Anachem chapter 4 na. Then on Friday, next week, we'll go back with this one. Or pwede naman dalawahin natin to next meeting. So basta matapos natin yung ganito na lang. Once we're done with the practice set for Anachem, we'll proceed with the continuation ng discussion natin dito, which is isomer. Isomer na kasi yung kasunod nito. So yun, we'll review isomers. Tapos magpropose ka kasi dyan ng mga isomers. Okay? So, ulit Josh, Tuesday ay Anachem muna. Tapusin muna natin yung practice set. Once we're done with the practice set, we'll proceed with the organic. Clear?
Opo.
Okay, so baka next week mag-upload na rin ako ng chapter 4. Chapter 4 na tayo ng Anachem, gravimetric method. And chapter 2 ng organic naman. So organic functionalities naman yung susunod na chapter nito. But we'll continue introduction to organic chemistry next week. So, mabilis naman tayo dyan kasi more on review siya. Tignan mo nga, naka 30 plus tayo na slide ngayon. So, 30 slides today. Kasi nga, alam na natin naman siya, tsaka nire-review lang natin siya. Okay?
Opo.
Okay, dahil dyan, I think we're good for today. I'll see you next week, Joshua. Okay. So,
Opo.
happy eating. Kain ka na
Sige.
muna.
Ayun
Okay.
po, bye-bye.
Mm-hmm.